This video is to go over the quiz questions in the Schoology quiz number 1. So the first question is asking, what does the formula above represent? And you'll notice that because I have what looks like f prime of x equals the limit as h goes to 0, this is the formula for the slope of the tangent line or the derivative. Okay? And this is just a straight up formula that you have to understand, okay? The slope of the secant line would not have the limit notation here. Okay, the second problem, what does the formula represent? This is literally just the slope of the secant line, okay? Think of it as like y2 minus y1 over x2 minus x1. x2 minus x1 cancel out to just h. So the slope of the secant line is the correct answer here. Okay, so this next question was a little confusing to some people. So let's go through and talk about it. Given a parabola, which of the following statements are true? Check all that apply. Okay, so the first thing says parabolas have a constant slope. Well, that's not true. Because parabolas actually have infinitely many different slopes. Okay, so this was one of your correct answers. If you look at a parabola, right, the slope is literally changing everywhere. Up here, it's very steep. And then as I continue down the parabola, it gets less steep. Here at the vertex, the slope is 0. Then it becomes more positive, right? Every different x value on the parabola has a different slope. So that was one of the answers you needed to pick. The next answer, the x value of the vertex can be found by setting the derivative equal to 0 and solving for x. This is actually true, okay, because we know at the vertex, the slope is 0, and the derivative or rate of change is basically a fancy word for slope, okay, so that would be a true statement. Now, the next thing is the slope of a parabola. Okay, again, given by the derivative, at a given x value can be found by substituting that x value into the original function. No, okay, we do not want to use the original function if we're finding slope. So again, I'm just gonna make up a function, right? So let's say f of x equals x squared minus 3x plus 2. The derivative would be 2x minus 3, right? If you wanna find the slope at a given x value, you need to plug that x value into not the original function, but the derivative formula. Okay, now let's go to the next question, all right? So which is the best description of the behavior? And basically what you want to understand is there are two turning points, right? The turning points, I'm just call them TP for turning points, are the points at which the y values turn around or change direction. So you could see before the first turning point, the y values are going up, and then they decide, you know what, I'd rather turn around and go down, okay? Here, again, the y values are going down, then they're turning around and going up. So I have two turning points. However, I also have one inflection point, okay? So we gotta really make sure we understand what that is. And the inflection point would be roughly here. So I'm gonna call this IP for inflection point. Remember, inflection point is a point at which the function changes concavity, okay? So maybe I can highlight this in a different color. If you look at this part of the function here, right? If I just trace this part of the function, hopefully you guys can see that okay. This part of the function is concave down, right? But this part here that looks like an upward shaped bowl is actually concave up. So the function changes concavity at this point, which is called an inflection point, okay? And notice at the inflection point, the y values are actually not turning around. They're decreasing the entire time. It's just the concavity changes. I go from an upside down bowl to an upright bowl and concave down to concave up. That's an inflection point. Okay, so the correct answer was this function contains, what you can see of the function here, contains 2 turning points and 1 inflection point. Okay, and our final question is the y equals x cubed parent function. And this says this function is increasing for all real numbers. That is a true statement, and let me explain why. Okay, so here at the origin happens to be my inflection point. Why is it inflection point? Because the function is going from concave down, right? And then all of a sudden it changes to concave up. So it changes concavity. Okay, but why is it increasing for all real numbers? Well, if I start down here, the function is increasing at a decreasing rate, as shown by the slope. Then the function increases at an increasing rate because the slope is getting steeper and steeper. So I'm increasing at a decreasing rate, I'm increasing at an increasing rate, I'm always increasing, right? I've never changed directions. The y values have continued to go up everywhere. So this was an example of a true statement. So I hope that helped a little bit. Feel free to visit my office hours on Zoom if you have any further questions.